Welcome to Tech presented by KaiZen, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KaiZen's own Phil Tomasello.
Thanks, William. And thanks to all who are joining me today for another session of Tech to Tech. We're going to talk about how temperature impacts your electronics cleaning process. To do that, I think it's first important to look at the process control and optimization. There are four key variables in established balanced cleaning, very important variables, including time, energy, solvency, and temperature. Time being total exposure, dwell time or impingement for aqueous cleaning. Energy, you're talking about PSI, flow, mechanical energy. Solvency, of course, being chemistry and the concentration of that chemistry. And again, temperature. There's really been an increased demand from manufacturers for greater reliability and performance of electronics. And we've also seen from manufacturers that they are creating component miniaturization. They're really densely packing more components on circuit boards. And that speaks to the need for looking, I think, a little harder at getting a balanced cleaning process in place for those PCBs. To do that, focusing on cleaning rate is really the first step. Cleaning rate in this sense is really defined by the rate in which a solvent or a cleaning agent dissolves residue. That's the static rate plus the mechanical energy, which is a dynamic rate. That's your process cleaning rate. Using the solubility parameter, Hansen solubility parameter, it gives us insight at our labs here at KaiZen into the material sets that dissolve residue. The testing that we do exposes flux residue to test coupons and various KaiZen chemistry, and that helps ensure that you have a proper match, the cleaning agent to the soil. This is an example on the slide of what you would see in a KaiZen matrix in our analytics, in our applications lab, scoring. Temperature has a huge impact on the solubility of flux. We know that. Great example here if you look at these jars, but it directly influences that solubility. And temperature significantly will impact the cleaning rate, chemical losses, energy consumption, compatibility, health, environment, even the life of your equipment. Optimum temperature range for electronics and PCBs really varies by individual aqueous cleaning process. Every process has a different spec, different materials, different procedures. But in general, Kaizen has found the most high reliability customers are running inline cleaning at no more than 1.5 feet per minute, with the expectation of cleaning 100% underneath those components. And the aqueous chemistry temps typically range in the 130 to 150 Fahrenheit range. Important to note also, temperature impacts different soil types differently. There's a sample chart here that you'll see, but no two fluxes are created equal. You'll look at different soil IDs, different solder pastes, and depending on the concentration, depending upon the temperature, some require more temp, less concentration. Some require more concentration and less temperature. So very important to review that when you're talking to your analytical lab, to your process lab for applications to work through all those variables. Another few charts here to illustrate my point, solubility and temperature. Typically, the higher the temp, the greater the solubility you're going to have. Again, here, if you look perhaps on the far right-hand side of this graph, just looking at the temperature, easily cleaned. In most processes, you'll find 60°C. The lower you go with Celsius or Fahrenheit, candidly, the lower the temperature, the more challenging you're going to have of a time cleaning without really optimizing that process. A lot of positive effects, positive things you're going to get from increasing your aqueous temperature. Certainly, a higher temp can help stabilize any cleaning process. It's going to increase that solubility of the flux. It'll help compensate for any ineffective aqueous chemistry you might be using. It will definitely decrease surface tension, the higher temperature of your bath on PCBs and components. When you talk about getting water to be skinnier, to get under those components, it's reducing that surface tension. It can also reduce inline or batch cycle times, certainly some negative effects. If you're increasing temperatures in your process without a formal process review and lab analysis, definitely can have a negative impact on the PCBs and components you're using. Certainly can cause potential damage to temperature sensitive metals, to the plastics, the coatings, ink, to the labels. Studies have shown, I think this is some very strong data here, that for every 10 degrees Fahrenheit temperature rise, the wash solution loses either by drag out evacuation. The losses you're going to have are going to increase by 30 to 40%. That's huge. Every 10% F temperature rise, you're going to see losses by evacuation or drag out increase by 30 to 40%. It's worth mentioning twice. The higher operating temps you see, they're certainly at some point going to reduce rinsability, certainly under the bottom terminated components. It's going to increase the need for longer exposure of your components in the rinse stage with higher chemistry concentrations. Candidly, this will result in higher operating costs of time, labor, resources, utilities. Important also to keep in mind, if you're operating at higher temperatures in your cleaning process, consider that this could increase an employee's odor sensitivity to the cleaning agent. It could also increase physical responses of headache, nausea, and eye burning. In conclusion, when we're talking about the impact of temperature on electronics, increasing temperature certainly can help stabilize that process of cleaning electronics by increasing that solubility of flux. And to some extent, that'll help compensate for some ineffective cleaning agents you might be using. Trying to adjust the cleaning temps without having a formal process review or lab analysis certainly can result in some unforeseen damage to those PCBs, to the coatings, to the components, possibly increase some health concerns. So you really need a balanced cleaning process using the proper chemistry and understanding and documenting the relationship between those key variables, right, of time, energy, solvency, and temperature. Of the many frequently asked questions we get, here are four of them. What is the optimum temperature of my aqueous cleaning process? And the answer is that really is based upon every individual process or project you have, the different soils, substrates involved. But the most common range is between 130 Fahrenheit and 150 degrees Fahrenheit. Question number two, will raising the temperature of my wash process allow me to reduce the amount of chemistry that I'm using in the bath? Yeah, in general, increasing wash temperature is going to compensate for ineffective chemistries you might be using. But chemistry also plays a key role in the cleaning process. So it's very important you analyze all the process control variables in context. That'll help you avoid higher temps simply damaging PCBs or machinery or possibly causing some of those health concerns we mentioned. Question number three, how high of a cleaning temperature is too high? And the answer is that, again, that depends upon the specifications that you have in the data sheets, the spec sheets provided on solder paste, on components, resistors, other substrates that you're using. But if you work with your analytical or your process lab, you'll be able to determine a range that is compatible for everything you're using. Final question here. How often should I evaluate my cleaning process and the aqueous bath concentration? And candidly, Kaizen says every week we urge people to analyze their bath concentration. It's important to use the proper test methods. And I'll stress that, very important that your team is using those proper test methods to obtain the accurate data. With that, I'll turn it back over to you, William.
Thanks, Phil. And thank you guys for tuning in to this Tech to Tech session. If you would like to discuss this topic further or have any questions that were not answered in the session, please contact your local Kaizen regional manager or send an email to tech at kaizen.com, and we will have someone follow up with you as soon as possible. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who would benefit from these sessions? The answer is yes. Just go to tech by Kaizen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.